Here we have LeetCode problem number 542 called 0-1 matrix or binary matrix, right? So this is a medium LeetCode problem, and I will admit it is a little bit of a tricky problem. It's on the more difficult side, but hopefully after this explanation in the live coding session, you'll have a better understanding of how to solve it, and you'll be able to solve it yourself later, right? So the approach that I'm going to take with this problem is a BFS algorithm, breadth first search algorithm. And I'll explain why I'm going to use that algorithm later on, but first let's just understand the problem statement. So given an m by n binary matrix called mat, return the distance of the nearest zero for each cell. So when it says m by n, that's just the dimensions of the given matrix. So m is the rows and n is the columns. You'll remember that if you've ever taken linear algebra in university. So for the binary matrix, that means it can only have zeros or ones, as can be seen here, right? And basically what you want to do is you want to change any given value to, instead of having only a 0 or 1, you want to have it equal to the distance to the nearest 0. So in this case, the distance from this 1 here to the nearest 0 up here, it's actually 1. So you don't want to change this. This should just remain 1, right? But let's say we're looking at this value here. The closest 0 is not 1 away. It's actually 2 away. You would have to go 2 up, or you'd have to go 1 to the right and 1 up, or 1 to the left and 1 up, right? So what does that mean? What should we do for the solution? This would actually, we'd have to change it to a 2, right? And as you can see, in this example, just doing it visually, that's the only thing you would need to change, right? That's the output right there, as you can that I'm highlighting under right there, right? But what about this? For a 0 itself, obviously you don't need to change that because it's a 0 in and of itself. It doesn't need to change, right? It's just the distance of the nearest 0 is just 0. It's nothing. So the zeros can stay the same, and then you just want to change. You just want to make sure the ones are the correct value, right? So think about this. How would we solve this in Java using a BFS solution? The reason we use breadth first search is because we're checking the neighbors, right? So we're checking here, is this a 0? Is this a 0? Is this a 0, right? We're not going deep. We have to check the neighbors first. That's why it's not depth first search, it's breadth first search, right? So in order to solve this in a BFS solution, the first thing I would do is I would make a new matrix. And in Java, a matrix is simply a multi-dimensional, a two-dimensional integer array, right? And I would declare a new matrix with m by n dimensions, right? And I would just make that new matrix empty, and I could call that matrix result, or res for short. And this is what the matrix would look like. It would just be an empty matrix of the same size with no values initialized yet. And then I would also want a queue. And basically this queue is used to keep track of the position of all the zeros. And we're gonna be keeping track of all the zeros because we're gonna use the position of those zeros in order to know how far away it is from a non-zero, right? So once we initialize this, we want to create two for loops, a nested for loops, right? And what this nested for loops does is it loops through here, starts here, it goes this way, and it continues all the way down through the whole matrix that is given, right? And as it travels through the matrix, essentially what it does is if it's a 0, all we want to do is add the position of the 0 to the queue. So in this case, it's the very first one. It would be 0, 0, and then add the 0 to the result matrix. Because when we return the result matrix, this is what's going to be returned, and the zeros are all good, so we can just immediately add it to the result matrix, right? And then the nested for loop would continue. It would go here. It would add the position of this one, so it would be row 0, column 1, because it's a 0, right? So instead of writing out the whole queue, I'm just gonna simply put an X next to the cells that have been added to the queue. And we'll use that for reference later, right? So now we have the zeros here, and then the nested for loops would continue. It would go here, 0, add it to the queue. We would check this one. Okay, it's a 0. We add it to the queue, and obviously we initialize that cell in the result matrix, right? And now what do we do if it's a 1, right? Well, for the result, we really don't know if it's going to be a 1 in the end, right? We have no idea, because right now we're just initializing the result matrix, but we're gonna have to truly figure out, is this only 1 away from a 0? In this case it is, or is it more? Is it 2 away? Is it 3 away? It could be anything, you know, because we're gonna have a variety of test cases, right? So instead of just adding the 1 to the matrix, we can flag it. And in order to flag it as something that we need to check, we can just use an arbitrary value. For example, we can just use -1. So in order to flag it, we can just put it as -1. And we'll use the -1, we'll check against that later on, right? So I'll just continue the process of what would happen in the nested for loop. It would just make this -1, and it wouldn't add it to the queue, because the position of this -1 is not important. Right now, for now, the position of the zeros is more important. That's why we need to keep track of those positions in the queue. So then the loop would continue. It would add 0, add it to the queue. Loop continue. These are all -1s, so we would just flag them as -1s in the result matrix, and we would not add them to the queue. Right. So at this point in the algorithm, we have this result matrix initialized as such. Now, what do we need to do? This is the part where we would actually do the breadth first search, right? So we would loop while this queue is not empty, essentially while there's still x's here, because that's how I'm representing the queue. While the queue is not empty, we want to continue the loop, right? And then in that loop, we want to start here. We start at the cell. The reason we start at the cell is because it's the first in line in the queue. It's the first thing we added to the queue, if you remember. It would be here, right? And then, so we start here, and we would check, okay, we want to check all its neighbors. So first we look up. Okay, up is not valid, so we don't need to do anything, right? Left, it's not valid. We don't need to do anything, right? Okay, to the right, it is valid, right? But it's a 0. We only want to do something if we see a flag. Now, the flag, remember, the flag that is -1. We decided the flag should just be -1. So to the right is not equal to -1. We don't do anything. The right is not equal to, down is not equal to -1. We don't do anything. So simply, it just gets removed from the queue because it gets pulled, and then we just move on to the next, the next element that's in line in the queue, the next cell in the queue, which happens to be this one, right? So we check left, it's 0. We don't have to do anything. Check up, it's not valid. We don't have to do anything. We check right, it's 0. We don't have to do anything. We check down, and what do you know? We hit the flag. So if we do hit the flag, that's when we need to do something. And the thing we need to do is actually we need to change this flag to the correct value. And what is the correct value? It's 1, right? Now, how do we know that? Basically, the reason we know that is because we take the current cell. Take the current cell, the value of the current cell, which is 0, and we add 1. So 0 plus 1 becomes 1. And that makes sense because if you think about it, if this is a 0 and we hit a flag here, right under it, all we do, it's 1 away. So 0 plus 1 makes sense, right? And then this gets removed from the queue, but also you need to remember, you need to add this to the queue as well, because we need to check against this cell later on, because this could affect how far away this cell is from a 0, for example. So we just add that to the queue, and then it continues, right? Now we're here. We check up, down, left, right. There's no flags, right? We continue. This is the next in line in the queue. Now we're here. Okay. Check up. it's a 0. We check right, it's a 1, right? But we still don't do anything. We're only looking for a flag. We're not looking for 1s, we're not looking for 0s, we're not looking for anything except the flag, which is -1. We check down, and what do you know? We hit a flag, right? So what do? We set the flag equal to the current cell value plus 1, which is 1. Then we add it to the queue, right? And then the while loop would continue while queue is not empty. It would continue, right? But it wouldn't hit this one here. It would actually go to here. If we keep track of, for me, I'm just mentally keeping track of what's in the queue. So it would hit this one here, right? It would check up. Okay, that's a 0. It's not. We do nothing. We check left. That's a 0. We do nothing. Check right. That's not valid. We do nothing. We check down. Okay, we hit the flag. Remember, we just change. All we do is we change the flag to the value of the current cell plus 1, which happens to be 1. And then we add that to the queue. And this is dealt with. It's removed from the queue. It's pulled, right? And now the loop continues, right? So what's left in the queue? It's the next thing up in the queue is actually this, based on the order that we put it in, right? So we're here. Check up, it's not a flag. We check right, it's not a flag. We check left, it's not a flag. Check down, it is a flag, right? So we have to deal with the flag, right? So what is the flag equal to? It's equal to the current cell plus 1. And why does this make sense? This is gonna be equal to 2, because if you think about it, if there's a 1 here, it's not a 0, right? It would have to go up and then up again to reach its next 0, to reach a 0. So in that case, this is correct. It's 2 away from a 0, right? And then we still need to add that to the queue to be checked later, right? And then if you remember, the next thing up in the queue is this value here. So we can pull it, we remove it from the queue. We check up, it's not a flag. We check right, it's not a flag. We check down, it's not valid. We check left, it's not valid. So we do nothing, right? We continue the loop. The next thing in the queue is here, right? So we pull it. We check up, it's not a flag. We check right, it's not valid. We check down, it's not valid. We check left, it's not a flag, right? So what do? We do nothing. Then we're at the last element of the queue. We pull it. Up, down, left, right, no flags to be seen, right? Okay, we pull it from the queue. So look, there's no more X's, right? That's what I use to signify something being in the queue. There's nothing left. So the while loop would stop, and at this point we're good. We just return result, and that's the correct thing to return. Right? This is exactly the result is exactly what the output should be, as can be seen here. This is just written in a way. This is just written in a way where it's showing the integer arrays, and then this is just written in a way that as a matrix, but it's the same exact thing. So that's the correct way to do it with a BFS solution, where the time complexity should be O of m by n, where m is the rows and n is the columns, and in the original given matrix, so it'd be O of m times n, right? That'll be the time complexity. So now let's just code this exact explanation in Java code. So here we are on LeetCode inside the problem, and we're gonna go ahead and begin coding it. And if you remember from the explanation, the very first thing you want to do is you want to make a new integer, multi-dimensional integer array that represents the result. But before we could do that, we need to get the dimensions, right? So how do we get the dimensions? It's actually given right here in the constraints. It shows m is equal to mat.length and n, which is the columns, is equal to mat at i.length, right? So we can go ahead and just make those variables to make things simpler. And then the syntax for the columns for n is actually mat at 0.length. Right, and now we just initialize and declare our 2D matrix that will be the result. And for now, it will be empty. And now we also need to declare the, let me fix that real quick, sorry. Now we need to declare the queue. So in Java, queue is declared this way. You would write queue, and then you would input what the queue will store. In this case, it's integer arrays, and we can call it queue. And then it would be new equal to a new linked list, because that's how you implement a queue in Java. So once we have that initialized, we would create our nested for loops. These are used to loop through the given matrix, as well as initialize our result matrix with the zeros and with the flag. In the case, our flag would be -1. So you can go ahead and create the nested for loops. I is less than m, I plus plus. So the outer for loop would loop through the rows. That's why it's I is less than m. Then if I make an inner for loop right here, I can change it to j. And then we would make it so j is less than n, and then j plus plus, and that will be used to loop through the columns. So now we want to check if it's 0. If mat at I and j, so essentially if the current cell being checked in the given matrix is equal to 0, we would make sure that the corresponding cell in result, which is ij, is also equal to 0, because the result that will be correct because the zeros don't change in the result. And then we also want to add it to the queue, queue.add new int new integer array with the coordinates in order to keep track of the location of the zeros. So once we have that in the queue, we can also make our else. And for the else, it's simply just, so we would simply have a location where it's not equal to 0. So in that case, we would just make it equal to the flag. So result at I and j would equal -1, which is the flag for us to know that, okay, this needs to be checked. This -1 needs to be checked. And now this part of the solution, after these nested for loops, we have everything initialized and ready. Now we're on the BFS part of the solution, right? The breadth first search. So I'll just write BFS. And now we need to check each directions. So an easy way to check directions is just creating a 2D int array, we can call it directions, and we can initialize it to -1, 0. So this first direction would check north, it would check up, because you're going -1 from the rows. And then this next direction, 1, 0, you'd be checking down. This next direction would be 0, -1. You'd be checking to the left because you're decrementing the columns and you're leaving the rows the same. Then this final direction would be 0, 1, which would be checking to the right. So we have those ready. That will come in handy. These directions will come in handy soon. And then we want to loop while the queue is not empty. Then we want to work our way through the queue, which right now is filled with zeros. And then we want to get the current cell that is at the front of the queue. So it could be this cell here, for example, and this cell would be 0, 0. So int cur is equal to queue.pull. So we remove the front of the queue, store it in cur, and that makes that way we know that the current row, so int current row, is equal to cur at 0. It's the first value in the integer array cur, and then int cur call is equal to cur at 1, which is the second value in the integer array. And now we have this set up, so we know our current row and our current column values, similar, kind of like our XY values. And now we can do our loop. So we want to loop through this directions array. So easy way to do it is just a for each loop. For int dir in directions. You want to first store the row, which is equal to cur row plus dir at 0. And this is basically saying, so if we're checking this direction here, it's basically saying, okay, change the row coordinate to go down to be -1. That means it's going up 1 row. It would be up 1 row. And then same thing for call, but we would use cur call plus dir at 1. And that would modify the current column if we're at, say, this direction or this direction here. Now we have a way of checking the neighbors, and all we want to do is we want to check, first of all, is the neighbor valid? So if row is less than 0, it's invalid, right? Because it can't be off the grid, less than 0. Or if call is less than 0, that's also invalid. Same thing, it can't be a column that's off the grid. Or if the row is out of bounds, so if the row is greater than or equal to m, that means it's out of bounds, because m, if you remember, m is the amount of rows. And if we're using indexes, it can't be greater than or equal to the amount of rows. Then call, same thing. If call is out of bounds, we want to check that, n, but it's n instead of m. And then finally, we want to check if we hit a flag. So result at row call, if this neighbor within result is a flag, is not equal to a flag, sorry, is not equal to -1, then if any of these are hit, so if it's out of bounds or if it's not a flag, we don't need to worry about it, so we just skip this iteration of the for loop. We just do continue, right? So that's simple enough. If it's not a flag or if it's an out of bound neighbor, then we just do nothing. We continue. But if we're in this for loop and then this if does not hit, that means it is a flag. So we'll do result at row call. So result at the neighbor should equal result at the current cell, so cur row cur call plus 1. That's basically incrementing the distance away from a 0. And this should make sense based on the prior explanation. Now we add that to the queue, add new int, and we're basically adding the coordinates of that neighbor that we just modified to the queue, because we want to recheck it again against other cells. So that needs to be added to the queue, right? And then this should be it, and this loop should work while the queue is not empty. It checks all the directions, adds what it needs to the queue if it does need to add anything, keeps going until eventually this pull will pull every single thing out of the queue and every single cell will be checked. Again, this is a O of m by n solution, right? So after this point, we should be able to just return the result, which is the resulting two-dimensional matrix. After it's modified, it would look like this here. This 2 would be different. If we run that, let's see if it works. Okay, I spelled length wrong. Let's see line 4. Length. Sorry about that. And then line 37, I spelled int wrong. That's a new one for me. Okay, let's see, line 37. Where are we? Inter. Okay, just int. Yeah, sorry about those silly mistakes. Let's see. Alright, and it looks like it works. Let's just submit to make sure every test case passes. And yes, so it does work with 14 milliseconds. So O of m by n solution. So thank you for listening, and subscribe if you'd like to.